an equation show the relationship between variables and other quantities in a situation? Think about this question during the lesson. What equation can be used to represent the relationship between the numbers of golf balls in Marley's and Tucker's collections? Here's what we know. Tucker has 159 golf balls in all. That's 3 more balls than twice Marley's golf ball collection. How can an equation represent a given situation like this one? If you have two expressions that represent the same quantity, then you can set them equal to each other in an equation. You can use a bar diagram to represent the situation. The top bar represents Tucker's collection. He has a total of 159 golf balls. The bottom bar represents the relationship between the two collections. We know there are 3 more than twice as many balls in Tucker's collection as in Marley's. How do you represent the number of golf balls in Marley's collection? The number of golf balls in Marley's collection is unknown, so we should represent it with a variable. Let's use M to represent Marley's collection. That's twice Marley's golf ball collection, plus 3 more. So that last section of the diagram represents the 3 additional golf balls. We can use the bar diagram to write an equation. Tucker's collection is equal to twice Marley's collection plus more golf balls. Now substitute the information into the equation. 159 is equal to 2 times M plus 3. The equation 159 is equal to 2 times M plus 3 can be used to represent Marley's and Tucker's golf ball collections. What does the expression 2 times M plus 3 represent in the equation? The expression 2 times M plus 3 shows the number of golf balls in Tucker's collection as an expression involving M, the number of balls in Marley's collection. Set it equal to 159, the number of golf balls Tucker has. Which equation can also represent the number of golf balls?
Select your answer.
You can choose any letter you want to represent the unknown quantity. We used M because it's easy to remember that it represents Marley's collection. Changing the numbers in the equation, however, would change the relationship between the quantities. Now you know how to write a 2-step equation to show the relationship between quantities.
Cole buys a new laptop for $335. He makes a down payment of $50 and pays the rest in 6 equal monthly payments, P. What equation represents the relationship between the cost of the laptop and Cole's payments?
So let's outline the information we need from the problem. So the laptop that Cole buys is $335. It also tells us he makes a down payment of $50 and pays the rest in 6 equal payments, P. So they're telling us the variable we're going to use for his payments will be P. And then the question is, what equation represents the relationship between the cost of the laptop and Cole's payments? They've already set up a bar diagram for us to use. So the long dark bar is representing the cost of the laptop. So we already underlined that the cost of that new laptop was $335. Then it also says at the bottom for the cost of this laptop, his down payment, which we know is $50. And then the monthly payments are P. We don't know what that is, so that's why that variable is there. So now we're going to create an equation based on our bar diagram. So the cost, again, is equal to the down payment and his equal or number of equal payments. Number of payments times the monthly payment. So now let's take that and create our numerical equation. So the total cost was $335. The down payment was $50 plus the 6 monthly payments, and that's P. And so we can simplify this to say $335 equal to 50 plus 6 times P. And again, like I've said in previous lessons, whenever you have that variable and that number or coefficient together, it does mean to multiply. That's why you can eliminate the use of the multiplication symbol and just put them right next to each other, and it still means to multiply.
The box contains 50 bats and weighs W ounces. One baseball weighs 5 25 ounces. A baseball weighs 25 75 ounces less than a bat. Write an equation that represents the relationship between the weights of a baseball and a bat in terms of the weight of the box, W. Use the word sentence to write the equation. The verb weighs is the equal sign of the equation. To the left of the equal sign is the weight of one baseball. To the right of the equal sign is the expression 25 75 ounces less than a bat, which is the same as the weight of one bat, minus the difference in weight. The difference in weight is 25 75 ounces, and the weight of one baseball is 5 25 ounces. To find the weight of one bat, divide the weight of the box by the number of bats in the box. The weight of the box is the variable W, and the box contains 50 bats. So the weight of one bat is equal to W divided by 50. Recall that W divided by 50 is equal to 1/50 times W. Now, substitute W divided by 50 for the weight of one bat. The equation is 5 25 equals W divided by 50 minus 25 75. The equation can be used to represent the relationship between the weights of a baseball and a bat.
Marcia and Tamara are running a race. Marcia has run 4 kilometers. Tamara has completed 3/4 of the race and is 2 5/10 kilometers ahead of Marcia. Write an equation that represents the relationship between the distances each girl has run. Let K represent the total length of the race in kilometers.
All right, let's look at the information that we are provided. It says Marcia has run 4 kilometers. Tamara has completed 3/4 of the race and 2 5/10 kilometers ahead of Marcia. We have to write an equation that represents the relationship between the two girls' distances. And it says K will represent the total length of the race in kilometers. So we know that Marcia has run 4 kilometers. So we have our 4 kilometers. And it says Tamara has completed 3/4 of the race and is 2 5/10 kilometers ahead of Marcia. So because she's ahead of Marcia, she's already run 3/4 of the race. So 3/4 of the total race, they said to let equal K. So if we multiply the 3/4 that Marcia has run times K, which is the total number or total length of the race in kilometers, we will get how much of the race that she has run. But then it also says that Marcia is 2.5 kilometers ahead of Marcia. So to solve for Tamara, we would have to subtract the 2 5/10 kilometers she is ahead of Marcia. So our 4 is the race Marcia has run. That's how much she's run. So to solve for Tamara, once again, we're going to multiply the 3/4 of the race that she did run times K, because that's the total number of kilometers that the race is. And then once we find her total of the race that she ran, we have to subtract it. And the reason we're subtracting is because it says she's ahead of Marcia. So if Marcia has only run this much, whatever she ran, we have to subtract 2.5 kilometers so that we know how much further Tamara has run. So this would be a sample equation that we could have. You could have written this in a different way, and we can discuss that in class. But this is an equation that you can use to solve this problem. Again, we're not asked to solve this problem, just to write an equation that represents the relationship between the girls' distance.
Claire bought 8 tickets for a total cost of $104. She had used a coupon code to get $3 off each ticket. Let X be the original cost of each ticket. Which of the following equations correctly represents the situation?
We are going to drag the tiles to complete the callout. So 3 times the quantity of X minus 8 is equal to 104. So the first one says $3 discount times the difference of 8 tickets and the cost per ticket. So $3 is being multiplied. That times tell us we're multiplying the difference of 8 tickets and the cost. So 8 tickets will be subtracted by the cost of the ticket. So that sounds, the first one we read sounds like that is this expression or part of the equation. And then we have 104, that would represent our total cost. The next one says 8 tickets times the difference of the cost per ticket and $3. So if we look here, it says 8 times X minus 3. That would not equal this one. Let's look at this one. 8 times the quantity of X minus 3. That is this one, because it says 8 tickets times the difference of the cost per ticket and $3. So that's the cost of the ticket and the $3. It says the difference of them, and then you have to multiply. So this one would be the one we would choose to match this one. And the total cost of would be here. Can't use the same one twice. Let's see. Let's see if we put. I don't know if we can use the one. It would be total cost. I put it in the wrong spot. That goes here. And it should be total cost, but yeah, this one should be total cost as well, but I don't think you can reuse the tiles. Okay, and this one says 8 tickets times the cost per ticket minus a total discount of $3. So this would be this one. You're multiplying the 8 times the ticket cost, and then you're subtracting that total minus that $3 discount. And then again, total cost. Oh, I put it in the wrong spot here. And then the 104 represents that total cost.
At the mall, Claire buys a hat that is 60% off and socks that are reduced to $5.49. She spends a total of $9.49. Let X represent the cost of the hat. Which of the following equations correctly represents Claire's shopping trip?
All right, let's look at the important information from this problem. First, Claire buying a hat that is 60% off is definitely important. And socks that are reduced to $5.49. She spends a total, very important information, of $9.49. Let X represent the cost of the hat. Which of the following equations correctly represents her trip? So we've underlined and identified our important information. So first, let's look at that 60%. So this hat is 60% off. For the equation purposes, we're going to take that 60% and make it into a decimal. So the way you take a percentage to make it a decimal, there is always this invisible decimal on the right side of the percentage. If you move it over 2 spaces, you now have a decimal for that percentage, which is 0.6 or 0.6 or 0 and 6/10. So now that we know the value of that 60% as a decimal, we can use it in our equation. So let's look at the, they have 0 and 4/10 times X plus $5.49 is equal to $5.09. So let's talk about the 0 and 4/10. We have decided that our percentage for 60% off was 0.6. However, that means that you're not paying for 60% of the cost, but that does mean that you're paying the remaining 40% of the cost. So that's where they get the 0.4, because 40% again has that invisible decimal over there, now has a visible decimal, and now your decimal for that percent would be 0.4. So Claire is paying that 40% left over for the cost of that hat. So you would multiply that by X. So far, this is correct. Then we have plus $5.49. So that's the reduced amount of the socks. So that part's correct. Then we look at the $5.09 that it equals. Well, that part is not correct because it tells us she spends a total of $9.49. So this first equation does not work. Now let's look at the second equation. We have the 0.4x, 0.4, that's correct. We knew that from the first one, plus the $5.49. That was also correct from the first one. And the total is equal to $9.49. So this one is our correct equation to use to solve for how much Claire was spending at her shopping trip. And the last equation here, 0 and 6/10 times X plus $9.49 is equal to $5.49. We know that she's not paying for 60%, she's only paying for 40%, so that part is automatically already wrong. And then it says plus $9.49. We know that part is wrong because that's the total amount. So that wouldn't be added into that either. So this one is our best choice.